So at first, we need to try harder to understanding the systems we're deploying. I mean, at the moment, artificial intelligence is no longer things we just hand code and understand and then we have complex interactions. It's literally stuff we don't understand. It's machine learning, and the reason it's so powerful is that it's able to do things with a lot of data that we can't do as humans. So we need to say, wait, if we don't understand it, we should slow down and try to develop technical and non-technical methods to understand this better. We should try to reverse engineer better. Every time we deploy one of these things, there should be an extensive study on what subtle things might be going on. We should try to understand and think very hard about their error pattern. When we have humans doing stuff, humans have failings. I mean, I don't want to sound like, oh, humans were perfect in decision making. Absolutely not. Humans have biases, humans discriminate, and we've spent, millennia grappling with it, and we try to build institutions. There's an error pattern to the way humans behave. And similarly, there's an error pattern to the way our artificial intelligence systems behave. And that error pattern is barely probed. We just deploy them and we say, oh, look, it does something that humans can't do as well. And often that's true. But the other question that's way underexplored is, wait, it's going to fail in things that humans might not fail at the same way. And understanding that is one of the ways I think we can try to guard against all sorts of systemic risk that comes up from deploying systems we don't understand. The second thing is we're coupling them to each other a lot. In, say, algorithmic trading, you have tons of algorithms that are coupled to each other. One does something, the other does something. It just spirals out of hand very quickly. And this kind of coupling of different machine learning and artificial intelligence systems that have error patterns that we don't understand really create a genuine systemic risk. Now, with the stock market, the worst case might be the stock market crashes and we do something like that. Would be horrible in many ways, but that's something you can probably fix in the sense that some people lose money and some people win money, and maybe there's some way that that's not catastrophic. But we're coupling systems making decisions to other things. We have critical infrastructure, we have threat detection, we have hiring systems that are being plugged into large databases on us. We have news and arts increasingly starting to use these artificial intelligence systems to decide what to highlight. It's shaping the way the public sphere operates through things like Facebook and Twitter, and Facebook especially using algorithms to a deep degree to determine what people see at the moment, coming close to 2 billion people. So there's all these ways in which we're deploying them and then coupling them to one another with all these cascading effects. And unlike, simpler artificial intelligence of the past, if you went to the programmers and said, what is your system doing? By structurally, they don't know, because the new systems that are so powerful, these machine learning or deep learning systems are exactly powerful because they do things with large data sets in ways that we do not comprehend. You're just it's more like training a dog to do something or raising a kid and then, crossing your fingers. And that's what we're doing. And I feel like, if we're going to put intelligent machines making all these decisions instead of us in such consequential ways, we should slow down and invest a significant amount of energy into understanding these systems to which we are turning over profound amounts of power. And that's, my worry isn't that artificial intelligence is being deployed. My worry is that it needs to be a three-legged stool, right? You need to have your artificial intelligence system, you need to have a lot of thinking about it, and you need to have a lot of investigation into it. And I'm seeing deployment going 100 miles an hour. The thinking and the sort of reverse engineering and tinkering and figuring out and accountability, all those, the other two stools going 2 miles an hour. And that's very unbalanced. That's not good. So that's the part I worry about.